Hey guys, it's Rishi once again, and today we're back with surface area. So what is surface area? Well, the surface area of a three-dimensional object is the total area of all of its faces. Now, in real life, we use the concept of surface areas for different objects when we want to wrap something, paint something, and eventually, while building things, to get the best possible design. So let's take a look at the example. The surface area of a cube is the area of all 6 faces added together. And as you can see, I've got a table showcasing a range of different 3D shapes, the total surface area, including the volume, as well as the lateral surface area, as well as the curved surface area. And again, if we take a look at the 3D shape cube, we can see that the total surface area is 6a squared, where we have a curved surface area of 4a squared, where a is the length of each side. In this video, we will be just focusing on the total surface area as per the 3D shapes given. Once again, just like our previous videos, don't forget to pause, attempt the question, and then press play to go through the solutions. Remember, practice makes improvement. So keep up the great work and let's get started. Question number 1. The diagram shows a cuboid, and we now need to find the total surface area of the cuboid. Let's plan out what this means. So with the surface area, this means we need the total area of all of the sides. So this is where we're working with the front and the back of the shape, the top and the bottom of the shape, as well as both sides. We go for left side and our right side. So now we've got that written out, let's go ahead and calculate it. So we know in order to get the front shape here, we have a 12 by 4. So we can simply say 12 times 4, and that's 48. And the back is also going to be 48. So in total, we have 96, and that's centimeters squared. And then for the top, we have our length as 12 and as our width being 5. So 12 times 5 is 60. That's our top, and 60 is also our bottom. So we have 120 centimeters squared. And then we go for our side. And that again is going to be a 4 centimeters by 5 centimeters. So 4 times by 5 gives us 20. And we know the right is also going to be 20. So that gives us 40 centimeters squared. So now with this all in mind, we can go ahead and add this all up for us. We know 120 and 40 is 160. And then if we go ahead and add 96, that will give us 256 centimeters squared. So our overall answer is 256 centimeters squared. So let's take a look at what I've done once more. I've gone ahead and worked out all of the different sides of this cuboid. That's the front, the back, the top, the bottom, and the left side, as well as the right side. Marvelous. I hope that was clear. Let's now move over into question number 2. So in this particular question, we're now faced with a triangular prism. And now as you can see, we need to find out the total surface area. So what's the first thing we're going to do here? Well, the first thing that we're going to do is simply work out the front of this prism. So as you can see, the front here is this triangle. And as we know, the area of a triangle is half times base times height. As you can see, our base is 12 and our height is 5. So 12 times 5 is 60, divided by 2 gives us 30 centimeters squared. And we know we have a front triangle and we also have a back triangle. So I'll also add another 30 centimeters squared. So now we've gone ahead and done the front and the back. Let's now move over to our bottom. You can now see that our bottom is this section here. Again, it's 12 by 10. So we can simply have 12 multiplied by 10, which gives us 120 centimeters squared. And that is the floor plan done. But then we have our side as well. And now for our side section, you can see that it's merely this section here. And that's again 5 by 10. And again, the 10 is coming at the bottom here, as you can see. So 5 and 10 will give us 50. And that again would be 50 centimeters squared. So what is remaining? Well, we've done our front, we've done our back, we've done our bottom and side, but we haven't done the top. And the top here is going to be this section. So if we take a look within our top, we would then have 13 multiplied by 10, which is 130 centimeters squared. So now we have all of our surface areas. We can simply go ahead and add this, and that would give us 360 centimeters squared. And that's merely it, 360 centimeters squared. So I hope you can see how I broke down this question into 5 different steps, depending on all the different sides that we have, with our front, our back, our bottom, our side, and our top, before putting it back together. Marvelous. Let's move over to question 3. Question 3 is very much the same as what we've just done now. So I'll give you some time to calculate this before I go through the solution. Marvelous. So question 3. Let's go ahead and calculate the front and the back of this triangular prism. Once again, we're going to go with a half times by 4 times 3, which is our base and our height. Again, we know 4 times 3 is 12, divided by 2 is 6 centimeters squared. So that's again for our front and our back. Now that is all done, let's go ahead and calculate it for the bottom. So again, the bottom, let's take a look at what we have. Again, if I draw this out, this is our bottom here. So again, 4 by 12, and that will give us 48 centimeters squared. So that's our bottom done. And then we need to go ahead and work out the side here. And if we take a look at the side, if I put it in a different color, you can see here that we're going to have a 3 by 12 centimeters, as this line here will also be the same as the back line here. So 3 times 12 will then give us 36. Okay, that's all done. Before finally working on the top, and again, if I put this in green here, you can simply see that this is our top section. So again, for our top, we will have 5 times by 12, which will give us 60 centimeters squared. And then once we've got all of the areas, we can add these all up, and that will then give us 156 centimeters squared. Marvelous. I hope that question was clear. Let's now move over into question number 4. So this diagram shows us a prism, and the cross section of the prism is in the shape of a trapezium. So the first thing we need to do is find out what the formula is to calculate the area of the trapezium. Remember now that our trapezium is the front facing shape here. So for those who don't know the formula of the area of a trapezium, it's simply going to be a half, where you have your A plus B multiplied by your height, where A is your 7 and 15 is your B. So let's go ahead and put that in. So we have a half, and we have 7 plus 15 times by our height, which is 6. So again, we know 7 plus 15 is 22, and we have to multiply that by 6, and that there gives us 66 centimeters squared once we divide it by 2. So we know this was 132. If we divide that by 2 there, it will give us 66 centimeters squared. And remember now, this is also for the front and the back. So we have to times this by 2. Hence, I'll put in another 66, and I'll label this as the back. So now that is done, let's go for our sides. Remember now, there are 2 sides, and we have our top and our bottom. So if we go for side What are we going to do? We know again it's 5 multiplied by 8, and we know that gives us 40, but there's another side, so I'll put in another 40 centimeters. However, our top and our bottom, they differentiate. So if I simply rub this out here, you can see that our top is much smaller than our bottom, which is here. So let's go for our top. And with this, you can simply see that we've got a 7 by our 8. So again, 7 times 8 gives us 56. But our bottom is going to be much larger. So if we go with our bottom, we know we're going with a 15 multiplied by 8. And that there gives us 120 centimeters squared. So with that in mind, we've now got our front, our back, our two sides, our top and our bottom. So again, we need to now get the total of this. And if we add that together, that would then give us 388 centimeters squared. So I hope you can see the pattern here, how we're breaking a shape down into all of the different sections, calculating the area and then adding it together to get our total. Okay, let's now move over to question number 5. Again, feel free to pause the video at any given time, attempt the question, and then press play, where we will then go through the solutions. Okay, let's get started. So now we have a total surface area of a prism, and you can see this is a compound shape. So what is a compound shape? A compound shape is a shape made up with more than one shape put together. For instance, we can simply divide this shape here, again forming 2 cuboids. And by doing so, we can then work out the area of 2 faces and then put them together. So let's start off with our front. And I'm going to go with the simplest one, which is this section here. I know that the entire bottom equals 8, and we have one section which is 5. So in order to calculate the top section, I will need to have 8 take away 5, which will give me 3 centimeters. So now I know I have a 3 by 7. So I can simply have 3 by 7, which is 21. And now I need to simply calculate the smaller face here, which again, you can see is a 3 on this section. So on this side, it will also be a 3. So we have a 5 and a 3 here, which gives me 15. And if we add that together, that is 36 centimeters squared. So that is my front calculated now. So what did I do? I split the shape up into 2. I then calculated the area of the first face and then the second face, added it together. And now again, because the front is equal to 36, the back will also equal to 36. So we have 72 as our front and back. Let's now move over to the bottom here. So what do you think we need to do for the bottom? So with the bottom here, we now know that we have 8 by 10. So again, that will give us 80 centimeters squared. But then we need to find the total of the top. And how are we going to do that? Well, the top is very much the same as the bottom. The only difference here is that it's been broken down into 2 different sizes. So we can simply say that the total for the top is also 80 centimeters squared, and that will give us 160 centimeters squared. Before finally moving over to the sides. So we've done our top, we've done our bottom. Let's now touch on the sides here. So just as we've just gone through the total of the top and how it's divided, likewise, the sides are also divided in the same way. So again, we've got a 7 here, and we know that we have a 10 on this bottom section. So a 10 is also going to follow on these sections here. So we can match this for a 10, and then finally a 10 here. So that would then give us our length as 10 and our width as 7. So we can have 10 times 7, which gives us 70 centimeters squared. And that is all of this side section here. And remember now, I'm just going to prove to you how the remaining opposite sides, which is here and here, are also going to equate to 70 centimeters. So let's take a look. We've now got a 10 centimeter here, but as our height here is 7 and we have 3 here, that means our height here is going to be 4. So that gives us 40 centimeters squared. whilst our 10 and 3 will give us 30. So now if we add our 30 and our 40, that will then give us 70, which is the same as our left-hand side. So again, 10 times 7 is 70, and we've got that for both of them. But then we can also see how we've made that. So again, if I just scroll up here, you can see we've got 10 by 4 plus 10 by 3, which gives us 40 and 30, and that is your 70 centimeters squared. So I hope that was clear. And all we now need to do is go ahead and add these together. So that's where we have our 72, add 160 and 140, which will give us 372 centimeters squared. Marvelous. You're doing really well, guys, so keep up the great work. We've only got 2 questions left now. Okay, question number 6. The diagram shows a box, and 5 of these boxes are going to be painted. And each pot of paint can cover 6 meters squared. So how many pots of paint are needed to paint the 5 boxes? So again, the first thing to do here is see that they've given us our metric unit as meters squared. So I'm going to convert all of my sides and lengths to meters squared. So we know that there are 100 centimeters in 1 meter. So 50 centimeters will be seen as 0.5 meters. Likewise, 40 is going to be 0.4 meters, and 100 centimeters is going to be 1 meter. Okay, I've now gone ahead and done that. Let's go ahead and work out the area of each of the sides. So let's go with our front. We know it's going to be 1 meter by 0.5. So 1 times 0.5 is going to be 0.5 meters squared. We know that our back and our front is going to be the same. So we have 1 meter so far. We then need to go for our left-hand side and our right-hand side. And this is just a way for you to separate each one. Now for the left-hand side and the right-hand side, so let's go for our side here. We know it's going to be 0.4 by 0.5, and the left side is going to be very much the same. And so we know that's going to be 0.2 meters squared and 0.2 meters squared. So now that's our left and right done. But then we have our top and our bottom. So let's go for top and bottom. Again, because it is a box, we know that our top and bottom is going to be the same as it's in the shape of a cuboid. So we know our length is going to be 1 meter by 0.4 as it is in the bottom here. So again, 1 times 0.4 will give us 0.4 meters squared, and it's very much the same for our bottom. So now what do we need to do? We need to simply go ahead and add all of our values. And that there would give us 2.2 meters squared. So now we've got our total area, which is 2.2 meters squared. We know that that is the area of 1 box. But the question states that 5 of these boxes are going to be painted. So what do? We have 2.2 multiplied by 5 boxes, which will then give us 11 meters squared in total. So that means that we would need to paint 11 meters squared. However, it states that each pot of paint can cover 6 meters squared. So if 1 pot equals 6 meters squared, then 2 pots will equal 12 meters squared. And that's exactly by just doubling both sides. So overall, we know that 1 pot will not be enough because we need 11 in total. So I'm going to opt for the 2 pots, which will then give me a leftover of 1 meter squared just in case. So in total, I will require 2 pots to paint 5 boxes. I hope that question was clear, and I hope you can see how I've gone and started with converting our shape from our centimeters to meters. I then calculated all of the areas of the sides before finally finishing off and multiplying it out to work out how many pots of paint we need. Marvelous. And let's move over to the final question. Question 7. So the diagram shows a cylindrical tank, and the tank has a top and a bottom. And now 4 of these tanks are going to be painted. And each tank has a diameter of 50 centimeters and a height of 1.5 meters. And each pot can cover 4 meters squared. So how many pots of paint are needed to paint the 4 tanks? So for those who would like to attempt this challenge question, please feel free to pause the video now. But for others, if you wish to continue, let's get started. So now surface area. So how do we work out the surface area of our cylindrical shape? So the first thing I'm going to do is write surface area for SA. And we know that equals to our top plus our bottom plus our side. And we know it's a circle. So in order to get the area of a circle, our top would be pi r squared. So we now know that our diameter is 0.5 meters. So what are we going to do? We're going to have our pi. We're going to divide 0.5 by 2, because if the diameter is 0.5, then the radius is 0.25. And for those who aren't aware, the radius is going from the center point to the circumference. Remember now that your circumference is this line here, going all the way around the circle. That's your circumference. So let's label that for those who are not aware. Your radius is going from the center to the circumference, and your diameter is actually the entire thing. And that is going from one end of the circumference to the other. And that is your diameter. So again, if the diameter is 0.5, then the radius must be 0.25. Marvelous. So now I've got pi followed by 0.25 squared. So again, for this question, we will be using a calculator, and we just need to calculate this one here. So by doing so, that would give us 0.19. I'll just write the entire number down. Remember, that's our top, and it's also going to be our bottom. So I'll write this down again. I'll circle top, and I'll also circle my bottom. So that's now done. So we've covered top and bottom. So now we need to go for our curved area. So let's write that out, curved area. Now for our curved area, we need to simply have our circumference multiplied by our height. So again, in order to work out our circumference, it's going to be 2 pi r, or pi times d, where d is your diameter. So again, we know our diameter here is going to be 0.5. So all I'm simply going to do, if I just make this a little bit larger, is simply have pi multiplied by 0.5 times by our height, which is 1.5 meters. So that again would give us 3 over 4 pi, or we could say 2.35619. Marvelous. So having said that, what do we need to do? We've now got our curved surface area. We've got our top and our bottom. So now we need to simply go ahead and add these together. Marvelous. And you can now see we've got 2.74 meters squared. But then it states in the question that each pot can cover 4. Well, then it states in the question here that 4 of these tanks need to be painted. So we're going to simply take our answer here and we're going to multiply this by 4. And that will then give us 10.99 meters squared. Remember, I will label this as surface area of 4 tanks. And now we've gone ahead and done that. It then mentions that each pot of paint can cover 4 meters squared. So right now, we know our paint is going to cover 10.99 meters squared. But then I'm going to go ahead and divide it by 4 again. And as you know, I will get the same answer as what I started with. But remember, we're dividing it by 4 meters squared. I'm just going to write 2.74 here. But again, we know that we cannot have 2.74 pots. So I'm going to round it up which will then give me 3 pots. So now we know that we will have 3 pots needed. So let's go through this once more. So step 1, and I'll do this in a different color here. I've gone ahead and I've calculated my surface area of the 2 circles with your pi r squared, as well as the curved area, which is your circumference times by our height. So first step, surface area. And then our second step is to add everything together. So by adding it, we now get the total surface area. And then we go ahead and we multiply it by 4 because there are going to be 4 tanks that are going to be painted. So that's my step 3 here, before finally dividing it by 4 here to get the number of pots needed, which is 2.74. But we know that we cannot have 2.74 pots, so we round it up to make 3 pots. And there we are. And that there brings us to the end of our session. I hope this gave you a clear insight and a clear introduction into surface area, into all the different methods that we had to follow, where we started off with a simple cuboid. We then worked our way through a triangular prism before showcasing you how to calculate the area of a trapezium and the total surface area, before finishing off with our problem-solving questions. Now, they did get harder as we went through these, but again, practice makes perfect and improvement. So keep up the great work. Don't forget to comment below on how you found these questions and if you would like me to dive deeper into the topic of surface area. Please don't forget to subscribe to our channel, where you will then be notified of when we upload our new videos. I hope this video was useful, and I'll see you in the next one.